So here we have a polynomial that I can factor. I have x to the fifth power minus x to the third power, or x cubed. So what I'm going to do first is I'm going to take out what they have in common, a GCF, a greatest common factor. So I ask myself, what do these two terms have in common? Well, this first term has 5 x's, and this second term has 3 x's. So I know that at the very most, they have 3 x's in common. So I can take out x to the third power. And when I do that, what am I going to be left with? How many more x's do I need to get back to x to the fifth power? Since I took out 3 of them, I only need 2 more x's. Bring down your minus sign in the middle. Now, since I took out x to the third power, what do I need to multiply x to the third power by to get back to x to the third power? I really don't need anything more except the placeholder 1, and I put that right here. So now on the inside, I have difference of squares, so I'm going to underline that. We can break this down a little bit further. The first thing I need to know is, what are the square roots of my terms on the inside? What would the square root of x squared be? That would be x. What would the square root of 1 be? That would be 1. So I bring down my square roots, and then I put this in parentheses, and I bring down the x cubed that we took out. Now, when I do difference of squares, I need to have a minus in between, but I also need to have a factor that has a plus in between. So I get x plus 1 over here, and I keep the square roots the same. So I still have an x, and I still have a 1. So now, in its fully factored form, I have x to the third power times x minus 1 times x plus 1. And that's how you factor a GCF problem like this.